stepwise. Criticisms and critics with stepwise, but I think it's more to do with how people interpret the results rather than the technique per se. I'll talk about that in a few minutes. So we go into statistics. Defaults are estimates and model fit. I always like to click the confidence intervals, which are going to be provided for the unstandardized beta weights and the intercepts. R-squared change is really only something I think you would use in a hierarchical multiple regression. We got descriptives, part and partial correlations, and then collinearity diagnostics. And I'm going to choose Durbin-Watson 2 because these are data that are time series data. So each case is a point in time, and it goes monthly. Those listed investment company discount premium values are monthly values, which increases the chances of having a serial correlation or an autocorrelation. I'm only going to test whether it's in the data. I'm not going to talk a lot about it. I'm just going to look at the output and go from there. The same thing with collinearity diagnostics and the collinearity diagnostics. So we'll go into options. There's another thing that I want. Oh yes, the plots. We'll go into plots. Now, what people typically do in multiple regression is they test the assumption of heteroscedasticity, and basically, heteroscedasticity is present when the variance associated with the residuals of the dependent variable are not homogeneous across levels of the independent variable. So basically, the strength of the prediction of the regression equation should be equally strong across all levels of the independent variable. And one way to look at that is to plot the residuals, Z residual, into the y-axis and the Z predictor into the x-axis. And it'll produce a plot, and I'll explain what that plot looks like. Well, I'll explain what we should be looking for in that plot. We can also look at the standardized residual plot histogram and the normal probability plot. So these are non-statistical approaches to examining heteroscedasticity. There are ways of actually testing heteroscedasticity from a statistically significant perspective, which I won't talk about in this video, but I will in another one. We're going to continue, and we click OK. And here's the output coming up. Okay, so the first table is the descriptives. This is just a generic mean and standard deviation with the sample size. So these are the means of the discount premiums. Most are trading on average at a discount to their net asset values, but some are trading at a premium, and these are the standard deviations. Standard deviations are fairly similar, but DJW has a much bigger standard deviation, as does AMH. Correlations, this is what the multiple regression is basically based upon, and what we have here are the correlations with AFI in the first column, but it's a correlation matrix, so it's the correlations amongst all the variables. But most importantly arguably most importantly is the correlations with the dependent variable, and we can see that DJW has the largest positive correlation with AFI at 0.73, and then next in line is ARG. So my hunch is when the stepwise multiple regression analysis is performed, it's going to choose DJW as the first inclusion into the model, and then it's probably going to go down to ARG. We can also see there's positive intercorrelations amongst the predictors, and that's why multiple regression is a useful analysis, is that it decomposes the unique contributions of each variable as a predictor of AFI, which is hard to do in your mind when there are intercorrelations amongst them. If there were zero correlations between the independent variables, you wouldn't really get the benefit of doing a multiple regression analysis, because each Pearson correlation would basically represent the unique predictive capacity of each independent variable. We got the statistical significance values here. I'll just point that out. And then the sample size. And then we get a table of the variables removed and entered. So I was right, DJW included first, and then ARG, and then AMH, DUI, CIN, and then it stopped. So after 5 the inclusion of 5 independent variables, the multiple regression based on the stepwise method, decided to stop because it could no longer find